Hey everyone, welcome back to the channel. I hope you're having a good day. One of you asked me a question recently. Actually, it was last night. I will answer that question at the end of the stream. And that is for you, marvelous, if you're hearing me. All right, today I'll go ahead to show you how I want to use Kubernetes in this project. And let me first close this and take you to the directory that is going to be responsible. So if you look at the project directory right now, or the folder structure, there is a directory called Helm. I'm going to use a tool called Helm to be able to help us deploy our projects to Kubernetes. Okay, so Helm is a tool that is used to deploy projects to Kubernetes. Or you can say Helm is a packaging tool and a templating tool for Kubernetes. So I'm going to explain to you everything that you need to know concerning Helm and how Helm works with Kubernetes. Good morning, marvelous. I hope you're having a good brand new day. So the first thing you need to do is to install Helm. Installing Helm is very, very easy. I will show you right in the browser. I'll say Helm. I think I had checked that page earlier. It's right here. So as it says installing Helm. And if you scroll down, you can install from the binary releases if that is something you want, or you can install using a script. Okay, like you see this command says curl. Then you can install using homebrew. So like me who's using a Mac, okay, I install Helm using homebrew. Okay, let me expand this so that you can read it properly. So I'll start from the beginning. To install Helm, you can use the binary release, or you can use a script, or you can use the package manager. Like if in Mac OS, you can use homebrew by saying brew install Helm. This is what I did, and it ran very fast. Or you can use choco install Kubernetes Helm if you are on Windows. So on Windows, you need the chocolatey tool. If you're on Windows, you can use Scoop or this other tool. If you're on Debian or Ubuntu, you can use this apt tool. Okay, so you can simply copy all this and paste in your terminal, and it will install for you Helm. Okay, for guys having Fedora, this is the command you use. You can use snap. You can use this for FreeBSD. Okay, so many ways. Or you can actually use the actual source code, okay, if you're on Linux and Mac OS, by cloning the repository, cd into Helm, and then running the command called make. So for me on Mac, I simply used homebrew by saying brew install Helm. And if I go to the terminal of my application, okay, I just expand this a little bit and I say Helm. Okay, you see that I have Helm installed. As simple as that. So it's a quite important tool that you're going to learn about today. And I'm going to show you how it links up with Kubernetes. Now, let's go to this directory. Okay. So I said Helm is a packaging and templating tool for Kubernetes and can help you deploy applications to Kubernetes. Okay, but the way it does that is by using a command. Okay, or okay, actually not a command. Let me first leave the commands alone. Okay, it does that by using what is called a Helm chart. Okay, so Helm deploys, okay, an app to Kubernetes using what is called a Helm chart. So what is a Helm chart? A Helm chart is a collection or a directory, okay, or a package So when you hear me saying package, directory, it's the same thing. So a Helm chart is simply a package or a directory of files that help you to achieve reusability. Imagine if you wanted, like, for example, to have deployment on your staging environment. You want to deploy to your uh, dev environment, to production, maybe to QA environment. And for each of these environments, you have maybe different sets of configurations and secret values. To achieve this, you're going to have so many Kubernetes manifests. Okay. So when you hear me saying Kubernetes manifest, think of it as a .yaml file, or a file having specification of your Kubernetes objects or Kubernetes resources, like either service, ingress, secret, deployment, a pod, no matter what. Okay. So a Kubernetes manifest is simply a YAML file having definition for a particular Kubernetes resource, like a deployment. As simple as that. So without Helm, you'll have so many files, okay? So many Kubernetes manifests. What Helm helps you to do is to have only a template. So you have like one file, okay, that you can reuse. You just pass values to it, okay, that you can reuse for development, for staging, for production, so that you have very, very few files, okay. So it helps you with templating, and templating helps you to have reusability and have few files, okay, to enable you use those same templates or those same files to deploy applications on Kubernetes for different environments. Please let me know if you understand that in the chat. Of course, for those who will be watching this after the live stream, you can leave a question in the comment section and I will get to it. So that is what Helm is and what a Helm chart is. So how do you create a Helm chart? It's very, very easy. You can now do it manually, or you can use it. I mean, you can create it using a command. So I'll go to my terminal and I'll say Helm, okay, create, okay. Then actually let me create a directory. Let me create a directory called make directory called I'll say Helm test, okay. Okay, let me say super app, okay, super app. Then we cd into super app, and then I'll say Helm create. I say deploy temp, okay, temp for template, and hit enter. So you see it says creating deploy temp. If I go into this directory called super app, okay, are you seeing it has a directory called charts, templates, okay, deployment.yaml, hpa.yaml, http route, ingress, nodes, service, okay, chart.yaml, values.yaml, so many files, okay, it has so many files. This is what the command helm create helps you to do, but you can also decide to do it manually. So I'm going to delete this one here, okay, and I created mine up here manually so that I explain to you Helm and Kubernetes in a step-by-step way without overwhelming you with all the concepts that Helm create provides when you create. Okay, when you do the command Helm create, there's so many things that come with it that you have to understand. Okay, so because I'm taking this as a step-by-step method to showing you how to deploy your applications on Kubernetes, I decided to eliminate, okay, the directory created by Helm create and do this the manual way, okay? But it all helps you to achieve the same goal, okay? Yeah, and the goal is simply to understand the concept, and of course you can use AI to generate for you the things and tweak them, but after you have understood the concept, and you can make decisions based on trade-offs. Awesome. So let me continue. So right here I have a Helm directory. Okay. Inside it, there's a directory called backend. So I have backend because I'm going to separate it, okay, from the front end. Maybe later I might have a a directory inside here called frontend, okay? Or maybe mobile, okay? Or maybe desktop. That's the whole idea. So Helm is the parent, meaning what we have inside here are Helm charts, okay? Then the first one is for the backend directory. I mean the backend project, as simple as that, which is ideally our FastAPI project. Now, I'm going to explain each of these step by step, okay? And of course, if you don't understand, let me know and ask me a question. And by the way, before I go very far, after this live stream, if you want to understand Kubernetes at a very deeper level, okay, I have a playlist in this channel that I covered, okay, sometime back, I think last year or early this year. You can have a look at it, okay? Kubernetes is very, very easy and very simple if you put in the time and concentration, okay? So let's go to values.yaml. So values.yaml, actually not values.yaml, let's start from chart.yaml, okay? So chart.yaml is an identity file. Let me reduce this a little bit. I hope you can see everything on my screen. If it is not visible, I can magnify it. All right, so let's start from chart.yaml in this backend directory. So chart.yaml is called an identity file, a Helm identity file. What does identity file mean? Okay, it simply means that this file is going to help us define certain things about our Helm chart. The first thing it defines is the API version. Okay, so on line 1, API version simply means that the format, okay, we are going to use for Helm is version 2. As simple as that. Then name simply refers to the chart's name, and our name is called backend. Then it has a description where you simply add more context on the name, which says Errorbound Ventures Backend API. Okay. Number 4 or line 4 is a type. Okay. And says the type is application. When you say type application, it simply means that this is going to be something you want to deploy and run. If the type is not application, for example, maybe type library, it will mean you simply want to have a library or a collection of configuration, which is not deployable, which is not runnable. But in our case, we have something that we want to deploy. So hence type application. Then after that, we have two versions, okay? Version and app version up here, okay? Do not misunderstand it. Do not get confused. I'm going to explain them. I'll start from line 1. Line 1 says app version, which is, API version, which is the format of how we have our configuration written. Then version refers to the version of our Helm chart, okay? And this is the first version. So you're seeing 0.1. This is the first version. Then app version refers to the version of the FastAPI backend that we're going to deploy. As simple as that. I'll repeat. Version refers to the version of this chart. Are you seeing this chart here? Okay, that this backend chart. This is the version 1 of the templates or the chart template or the Helm template that we have. Okay, then app version is the actual version of the FastAPI application we are going to deploy. As simple as that. So that's the difference in those two. And they typically do nothing. They're just informational, okay? They're informational. They don't do anything to your application. It's simply informational to the person using your application, okay? So that they know that, okay, I'm using version 1 of the backend. I'm looking at version 2, okay? And maybe version 2 has features that version 1 does not have, or it has maybe deprecations or updates, something like that, okay? So that is chart.yaml. Make sure you name it like this, okay? This name, chart.yaml, is case sensitive, okay? If you put it as a small c or only uppercase letters or only lowercase letters, you'll have issues, okay? Helm will throw an error. So it is case sensitive. Please keep it as chart.yaml, okay? All right, now I'll move on to the next directory. So I'll close this and go to values.yaml. Okay. So values.yaml is another very easy YAML file to understand. Okay. It is a file, okay, which holds settings for Helm. Default settings for Helm are stored here in values.yaml. And I'm going to explain to you these settings. In fact, many of them are very familiar with what you have already seen. So the first one up here, okay, is configuration or a setting for the image you're going to use, okay? And it says that the repository, okay, or the name of that image is called arrow backend. And it has a tag called local. Then it has a pull policy saying if not present. What does this mean? It simply means that if there is a local image, for example, on my machine or on a node you're using on the internet, use that image, okay, called arrow backend with the tag local. So ideally, if you were to use Docker, okay, through Docker, you'll have something like arrow backend, full colon, then local. Okay, this is how it would be like. So it's a combination of the repository and the tag, or the image name and its tag, as simple as that. Then if it's not on the local machine or on the node, then it is pulled from a registry like Docker Hub. That's what the pull policy is all about. After that, we have another section called API. Okay, so here in API we have the definitions, okay, of our replicas. Okay, so you see in line 7 says replicas 1. So this simply means how many instances, okay, or how many copies of our FastAPI pod do we want. Okay, so for development I'm simply keeping it 1. Okay, but later we shall look at how to increase it. Okay, and how to increase it between, for example, like if there's high traffic, okay, make them maybe 10 pods. If there's low traffic, maybe make them only 5 pods. Later scale down maybe to only 1. Okay, depending on maybe stuff like other metrics like CPU. Okay, if there's high CPU usage, do this. If there's low CPU usage, do this other. Okay, what enables that is this other configuration on line 8 called HPA. Okay, so HPA in full is horizontal for H, P is for pod, A is for auto scaling. So in full, horizontal pod auto scaling. Okay, so actually it is horizontal pod auto scaler, not scaling, but auto scaler. Okay, but the same concept. And for now, I have disabled it. Okay, later I will, as we advance, I'll show you how we're going to enable it and how we're going to use metrics like memory, CPU usage, traffic, okay, to horizontally scale our pods, okay, to increase the number of pods or reduce the number of pods. As simple as that. And if you don't know what a pod is simply the smallest deployable unit in Kubernetes. Okay, so I hope that is getting into your mind real deep. So for now, it is disabled. Then we shall have only one replica or one copy or a duplicate of our application. Then we have service. Okay, this simply says that we're going to expose, okay, our pod, our backend pod, or our FastAPI pod on port 80. Then we have ingress. Okay, ingress simply refers to external traffic from the internet coming into our pods, okay, or to our backend, or to our Kubernetes infrastructure. That's what ingress means, okay? And for ingress to work, you need an ingress controller like the AWS load balancer, okay, in AWS EKS. But for now, we don't need it, okay? Later, I'll show you how to do it. That's why you're saying it says enabled false, meaning right now we're not going to deal with external traffic from the internet. If we want to test it on our local machine, we shall use the concept of port forwarding, okay? And I'll teach you port forwarding. Of course, those of you who followed me when I was dealing with Kubernetes, you'd already know the things. We're just reinforcing them and making sure that everybody flows along with us. So ingress is disabled, as simple as that. Then we go on to config. So config is simply a section that talks about settings for your project that are non-sensitive. Okay, and I put here an example like the environment, the front-end URL, okay, and a number of things. Okay, simply non-sensitive information. Okay, and of course I won't go through each of them because you actually know them. Then down here, we have secrets. Secrets is configuration, okay, or environment variables that are sensitive. Okay, that's why they're called secrets. Again, for config, you're dealing with environment variables which are non-sensitive. For secrets, you're dealing with environment variables which are sensitive. Okay, understand that. Now, since these are this time we are saying that don't create any secret. Okay, so when you say create false, we are saying do not create any secret. As simple as that. Then it says existing secret name, backend secret. Saying this means that there is an existing secret, okay, called backend secrets that you should use. Okay, that is why we have said on line 34, don't create it. Don't create it because there's already one existing. Okay, understand that. Then of course down we have data empty as an empty dictionary, you'd say. Why is it empty? Because we have an existing secret called backend secrets that will be used in for production. So it shouldn't be created, and this data block should not be created. Otherwise, if create was true, then we can supply data here, and I'm going to show you. So let's go into the other file. So values.yaml is automatically loaded by Helm. So understand that it is automatically loaded by Helm for us. And I'm going to explain to you how it is loaded. I'm going to show you where these values are picked and injected into the Helm template. So I'll close this and go to values dev. Okay. So think of this. Values.yaml is loaded automatically for us, and we shall use it in production. Okay. But values dev are settings we can use for only development. Okay, so you can have values dev, you can have values staging, values QA, values testing, whatever. Okay, so values dev is the same file as values.yaml. Okay, so values.yaml is loaded automatically, but we can tell Helm to override the values.yaml using values dev. How do you do that? Okay, let me show you. Okay, to do that, you can simply, let me get out of this directory. Oh, it was removed. So I need to get back. All right, so I need to cd into projects. All right, we are back. So now you can say Helm, okay? Helm, then template. So template is a command in Helm which helps you to generate the Kubernetes YAML files, okay, from the Helm configurations, okay? Then you can call what is called a release name, okay? The name of the release, what you're releasing right now. You can call it arrow backend, okay? And specify the Helm, the Helm chart. It is in Helm, okay? / backend. Then if I say -f now is used to specify, okay, that Helm chart. I'll say it is, I'm not the Helm chart by the values. I'll say Helm / backend / values - dev.yaml. Okay. Once you use -f, okay, you specify the values file. Okay. So why I showed you this command is to teach you and show you that values dev.yaml is used, okay, to specify your own values file, for example, for development, okay, and it will override all the values in values dev.yaml, okay, as simple as that. And we're going to see how to use that command soon. All right, let me minimize this and explain to you. Now, let's start with from the top, okay? So you see here, I have config, okay? So in values.yaml, if you go to config, I have redis URL, okay? So if I do the command I showed you and say -f values dev.yaml, it will redis URL here on line 2 will replace what is here, you get. If I use redis host on line 3, will replace redis host on line 22, okay? Kafka bootstrap produce servers, okay? Kafka bootstrap servers on line 4 will replace what is here on line 24. As simple as that, okay? All right. Then, so what is in values can be in values dev. Then for secrets, this time we're saying create secrets true, okay? And it will be, these secrets will be created using this data argument, okay? So database URL, secret key, guard API key, all these, okay? But like I can see that these are just sample data, okay? They're not true. It's not true data, okay? So don't be tempted to put here sensitive data, guys, okay? I am going to show you how to use sensitive data, okay? And to actually to tell you something is that Kubernetes and Helm will do a base 64 encoding on your secrets, okay? But have it in your mind that base 64 encoding is not encryption, okay? It will base 64 encode your secrets. That is very true and that is very good, but it will not encrypt your stuff. So have that at the back of your mind, okay? Awesome. Now let's move to something else, okay? So I hope now you understand values.yaml, okay? These two. So I explained to you what is Helm, okay? What is a Helm chart? How Helm relates to Kubernetes. I explained to you what chart.yaml is. We went to values.yaml, values.dev.yaml. Now let's go to templates, okay? And it's very simple. Like I told you, these things in tech, once you put your mind to it, okay, cut off distractions, create time to think about it and reason, it's very easy, okay? And my job is to show you how easy it is. Great. Now, let's now go to secret.yaml. Actually, let's start from ConfigMap, okay? And I explain to you what ConfigMap is. Remember earlier, I told you, okay, that in Kubernetes, okay, we have two things. We have config and secrets, okay? In values.yaml, we had config, okay, right here, and secrets, okay? Go for values dev, we have config and secrets, okay? In Kubernetes, when you want to deal with Kubernetes, okay? Kubernetes has something what it calls Kubernetes resources or Kubernetes objects, okay? An example of a Kubernetes resource or a Kubernetes object is a deployment, there's a service, there's a config map, there's a secret, okay? These are objects. Now, a config deals with non-sensitive environment data, okay? Well, a secret deals with secret or sensitive data, okay? Now, I'll explain to you this file before, okay? But even before explaining to you what is in this file, what we have here in values.yaml, secrets, okay, is injected into secrets.yaml, okay? What we have here in config in values.yaml is injected into config map. And I'm going to show you how and where it is injected. However, I'll repeat this again, guys, okay? Kubernetes has resource types or resource objects or resource type objects. One of them is a secret, config map, a service, a deployment. The others that we shall see, okay? One of them called a config map is one which deals with non-sensitive data, okay? And the data that is in here in config, okay, like environment, origins, redis URL, are injected into config map, okay, or are rendered into config map. Those in secrets are rendered into secret.yaml. As simple as that. Now, let us now go and see how this happens. And I remember I told you that values.yaml is loaded automatically by Kubernetes, and values.dev overrides what is in values.yaml. So let's start with ConfigMap. So you go to ConfigMap here. Okay, you see the first line says API version. API version here, 1, refers to the version 1, the core Kubernetes API version. Okay, and ConfigMap belongs to version 1. Then it says, what kind of Kubernetes resource do you want to create? Are you seeing this? The kind is a config map. Okay. If you go to secret.yaml, okay, look at the kind. It says secret. Okay. This one says kind, secret. This one says kind, config map. Okay. This is metadata. There's some extra information about this config map. We give it a name. It says name. Okay. We have 2 curly braces at the beginning and other curly braces at the end, then dash config. Okay. In between here, it says .release.name. It will render for us the release name for us. Okay. So what you're seeing here, what I've highlighted is what they call the Helm expression templating language. Okay. It's where variables, okay, all values of variables are rendered into the template for us. Okay. And you're going to see how this works. Okay. So what is the release name? Remember when I typed a command, let me clear this, okay? When I said Helm, okay? Then I said template, okay? Template, remember the command template helps us to render, okay, our Helm templates into Kubernetes manifests without deploying the app, okay? Helm template, then says error dash backend, okay? This word, error backend, is the release name, okay? So when it is rendered, okay, this name, okay, will be something like it will be error backend, okay, dash config, as simple as that, okay? This will be evaluated as this on line 5, okay? Understand that, very simple. Then after that, we now have the actual data. So we have again the expressions here, okay? It says a range, okay? It says, think of range as a for loop, okay? So it says range, okay? Then at the end it says end, you get. So it's like starting a for loop, okay, or a loop, and then ending the loop, as simple as that. So it says for every value, okay, dot config. So what is values, okay? Values is simply referring to this value, this file here, values.yaml or values.dev, depending on the one you're using, okay? So values, inside values, we have config. You see this config? So values.config, okay? Or values.dev.config, depending on the one you're using. So in config map, we have values.config. It says for every key and value in the values.config, okay, we want to put them in variables, okay? So $sign here are the variables, okay? And then we simply print the key, output the key here, okay? Put a full colon, okay? Then put the value. So for example, it will pick values.config, values.config, okay? It will put environment, development, front-end URL, the front-end URL, Redis host, Redis, like that, Redis post, that, okay? Then after that, we pipe and say quote. This simply ensures that every value is wrapped in quotes, okay? And you're going to see that when we actually render it. We're going to render it at the end. It is wrapped in quotes because Kubernetes expects to have only and only strings, okay? Kubernetes expects to have only strings. So I hope you get that. So that's what ConfigMap is all about, okay? It will help us render all the secrets, not the secrets, all the non-sensitive configuration for our environment variables. I hope you get that. It's very easy. So you see how now the templating is working? It is helping us to reuse this in a easier way that it can be supplied to Kubernetes. As simple as that. All right, so we go to secret.yaml. Now, secret.yaml has interesting bits, okay, that we need to also understand, okay? And I'm going to explain them in a bit. When you look at the first line, okay, I have a distraction here that I want to end. Sorry. So if you look at the first line, you simply have an if statement. Okay. So it also starts with two curly braces, and at the end there are also two curly braces. Okay. That's how you define the what is it called? The Helm expression language. Okay. And if you look at the very end, okay, on line 11 simply says end. So that's how you end. Sorry, let me zoom out. That's how you end an if statement. Okay. All right. So I've handled the distraction. Sorry. Let's continue. Okay. So it says if values.secrets.create. So what is values.secrets? Values refers to this values file. Okay. Of course, and a values object will be created. Then .secrets refers to this. Okay. Secrets. Then create. Okay. If it is true. Okay, so it says if the value here is true, do this. If it is not, if it is false, do nothing. So everything here, okay, from line 2 to line 10 will be rendered only when secrets.create is true. So for values.yaml, nothing will happen here. But for values dev, we have secrets.create to be true. So it will be loaded. Okay, understand that. You get. So values.secrets.create will be true for values dev, okay? But for the other one, values.yaml, it will be false. So we have the API version. Again, it refers to the core API version for Kubernetes, which is version 1. And the kind is a secret. Then we have metadata, okay? So metadata simply refers to the extra information we're giving this secret, okay? And says meta, okay, dot release name, okay, then secrets, okay? And I told you release name comes from what we add here, okay, in the terminal. After saying template, Helm template, then you add the release name. So for this case, it will be arrow dash backend as the release name, then dash secrets, okay? As simple as that. That's what this object will be named as. Okay. So this secret will be named as arrow-backend secrets, or whatever release name you give. It doesn't have to be specific. Then we have here type being opaque. Okay. So actually this type opaque is the default. Okay. It simply says this is the generic secret type. Okay. And Kubernetes does not enforce any kind of structure or validation on its contents. Okay, it means you can store any key value pairs such as API keys, database power, passwords, GWT secrets, tokens, configuration values, anything. Okay, that's what opaque simply means. I just added it here to teach you something extra, but it's the default. Okay, but in simple terms, it simply means create a generic Kubernetes secret. Okay, yeah, could be anything. Then we have on the next line, line 7, string data. Okay, string data simply means it's a plain string. Okay, it's a plain string. Yeah, also something added just to show you. Okay, then on line 8, again, we have, think of it as a loop. Okay, saying for every values. Okay, so in the values object, again, I said values object will be created from the values.dev. Values.yaml files, either value.dev or values. Okay, and in the secrets in it .data. So secrets of data for values.yaml, it is empty, okay? Because we won't need to be creating secrets because create is false, okay? And we shall have an existing secret that I'll show you. But for values dev, okay, data is required. You understand? Okay, it is right here. So for values dev, we shall have this loop working. Okay, so this end is for this if statement up here. Then this other end is for this range. Okay, so pick every key and values from the values.secrets.data and render the key, put a full colon, then render the value, and every value should be wrapped in quotes. Okay, and it's going to be plain string data. Okay, and of course, being plain, like I've told you, Kubernetes does for us a base 64 encoding. Okay, but remember, base 64 encoding is not encryption. All right, so we're done with that. Now let's go to nice stuff. Okay, we're almost done. The next one is deployment.yaml. Okay, and marvelous, I've not forgotten, I'm going to address your question in a moment. So in deployment.yaml, we now get a Kubernetes resource or a Kubernetes type, this time called a deployment. Okay, so if you look at the API version here, it says apps v1. Okay, this refers to the API version, as simple as it's like I've been explaining. Okay, but for the deployment, we have to say apps v1. This is the syntax, and the kind, the same is a deployment. Okay, right now there are things that should now be common to you in your mind. Okay, for this, for ConfigMap, the kind was ConfigMap. For secret, the kind was secret. Okay, if you look at service, you see that the kind is service. Okay, very simple, guys. Now let's continue. I'll close this. I'll go to API deployment. Okay, then we have metadata. Okay, again, the name of this deployment, okay, will be called the release name. Okay, and again, release name comes from this arrow backend release name that we use when we are doing Helm. Okay, the Helm template, then the release name. Okay, and it will be arrow backend dash API. Okay, this is simply the Helm templating language. Then when I open here, we have the spec. Okay, spec simply stands for specification. Okay, and the first one tells us about the number of replicas. Okay, it says get the value of the replicas from values.api.replicas. Where do you get this? You go to values. Okay, we shall have a values object created. Okay, and we see that values, okay, dot API dot replicas, and for now this is 1. Okay, so even here the value will be 1. After that we have a selector. Okay, so selector match labels app release name API. Okay, now let me explain this. A selector is simply a tool to search and find. Okay, it is saying look for replicas or for pods which are named, okay, arrow backend dash API, because our release name would be arrow backend. But again, like I said, don't cram. It could be anything. You can say maybe arrow API. Okay, what you're seeing me typing in a terminal here. Okay, could be arrow API, or it will be maybe fast API pod, or it could be your, I don't know, JavaScript or Node API. Okay, so just don't cram. It can be anything. Okay, for me, I just decided to call it arrow backend. Okay, as the release name for the Helm. So here it will be to say look for arrow dash backend. That's the release name. What's this thing? Hallucinating. Okay, dash API. As simple as that. So a selector is simply saying find everything that matches the following label. Okay, that the app should be called this. Find things that match this. As simple as that. Okay, I know I'm explaining this very carefully. It confuses many people. Even me in the beginning, it used to confuse me a lot. Okay, understand that the selector match labels.app is simply a label to help you search and find, okay, a pod with a particular label. Let's move on. Now we go to template. So in template, we have also a number of things. Okay, we have metadata, okay, labels, app, and it has the same value up here. Okay, know that selector.matchlabels.app is going to match with template metadata labels.app. Okay, so let me explain something here before we continue. Okay, what you have here, okay, up here, okay, is information, okay, or specification for the deployment. Okay, what you have here is information for the deployment, specification for the deployment. What you have on line 10 in template, okay, is specification for the pod. Understand that. And what I showed you here, this line here, okay, must match up here, okay, Why? In Kubernetes, when what, like I've told you, the template is what is responsible for creating the pod, the configuration for the pod. Okay, there'll be a pod with the label release name dash API. Okay, understand that because of line 13. Okay, we shall have pods, FastAPI pods, or Node.js pods, or Express pods, or Java pods, or PHP pods, depending on your programming language that you're using for your backend. Okay, called arrow backend dash API. Okay, they'll have a label. Okay, and that label will be created because of this line 13 here. Okay, but then your deployment needs to find them. Okay, because a deployment in Kubernetes manages pods. Okay, a deployment creates your pods. It makes sure, like, for example, if you desire to have 5 pods and there are 3, the deployment makes sure that it increases your pods from 3, okay, to 5. Okay, if any pod dies, okay, the deployment helps you to do auto heal them. Okay, if a pod does not need to receive traffic, I mean, if a pod does not need to receive traffic, the deployment handles that. So a deployment manages pods for you so that you don't have to hassle about it. Okay, and those pods are given labels by this code or the specification or configuration on line 13. When Kubernetes or when a deployment wants to find your pods, it uses line 9. Remember, I told you line 9 is a find and search label. So using line 9, okay, it tries to look for labels that match line 13. That is why line 9, okay, the value of line 9, the label at line 9 should match the label at line 13, because using 13, a label is created. But using 9, a label is searched for. So you use line 9 to search for line 13. Line 9 is a configuration or specification for the deployment, and line 13 is a configuration for the pod. Okay, so a pod is labeled like so on line 13, and the deployment uses line 9's label to find line 13. Okay, so ideally we're using a deployment has a label, okay, says search and find using this. Okay, so it will be like this. Let me show you. Arrow backend API, okay, right here. Then also here it will be the same, so that the deployment uses this to find pods labeled that. As simple as that. Okay, but of course pods are given different names. Okay, so label and name are different. Your pods actually have something like lab API, maybe XX, I don't know, something random like that. Then another pod API, like that. Okay, so that's a pod name. Okay, but all of them having the same label. That's why a label is very important. The pod names keep changing. Okay, that's why it's important to have a deployment managing them for you. All right, so I'll close this to make it easier. Then inside here, we have now interesting specification for the pods. Okay, the first one says auto mount service account token to false. Why? This is because Kubernetes always mounts a token, okay, to every pod, and this token can be used by your application in the pod, like your FastAPI application, your JavaScript application, your Node.js application, whatever it is, okay, to communicate or to authenticate if it wants to make requests to the Kubernetes API. Maybe you've written your Python code or JavaScript code and you want your code to make a request to the Kubernetes API. To do that, you need to authenticate with the Kubernetes API. So you need that service token, okay? But here I don't need it. That's why I've said false, okay? It helps us to avoid unnecessary leakage of tokens, okay? Of sensitive information inside the pods. Then inside here, we have now the containers, okay? And we have only one container, and that container is given a name called API, okay? If I open here, you see that we have similar stuff. Let me close this, okay? And actually, you're going to appreciate the previous 2 or 3 videos that we have in this playlist. Now, line 19, okay? Says image, okay? The image name comes from, is a combination of the values.image.repository from the values object. Okay, where is values? Values simply here. Okay, down what I showed you here. Okay, we have values.image.repository, which is up here. Okay, image.repository. Then a full colon. Then we have values.image.tag, which is right here. Okay, image.tag. So it will be arrow backend local. Okay, and I'm going to show you this, how it is going to be brought out to us. Then we have image pull policy. Says values.image.pull policy. The values object will be created from this values.yaml, and we have image. Where is it? Values. It says values.image image.pull policy. Okay. For some reason, I don't know why I was getting lost. Maybe I'm getting tired or something. Okay, so you get it. Values.image.pull policy. As simple as that. Then we have another one right here. This is the command. So this will be the command for running the FastAPI project. Okay, simply says find a directory called app backend virtual environment bin FastAPI. But even remember, we made it easier earlier. Okay, so we're going to simplify this. We even don't need it, but it's simply a command we're using to run FastAPI. Okay, or it is giving us a location to the FastAPI installation or binary, something like that. Okay, then the arguments. This is the arguments we give to the FastAPI command. Okay, which is FastAPI run main.py on port 80, and the host is that. Okay, the usual thing we've been doing. Okay, then when you open up here, we have an application port. Okay, we have a port. The port is named HTTP. Okay, this is a port name, just a name, just a label. Have that in your mind. Okay, and says container port 80, which this is actually information saying we have a port at port 80. Okay, but that port 80 will be opened by FastAPI. Okay, by this command here when you say minus port 80. So container port 80 is just, can I say, documentation. Okay, but it will be actually opened by the FastAPI application. Then after that, we have env. Okay, so we have our environment variable. Okay, is going to be built from the config map and the secrets. You get from config map, we say this release name.config. It is referring to this. Okay, I see this name here. Okay, up here. Arrow, it will be arrow backend config. Why? Because arrow backend is the release name, then dash config. So it will be used here. Okay, the config map reference will be the same name. So you see how Helm is helping us reuse values or variables. Then the secret reference will be, we shall say an if statement. Remember, this is an if statement. Okay, and we end it down here. Say if secrets.create, meaning if this value here is true. No, this one here, sorry. If secrets.create is true, okay, then we say that the release name will be arrow backend dash secrets. Otherwise, else, okay, we use the secrets.existing name if it is required. Okay, as simple as that. We use the secrets.existing name. If you go to values.yaml here, existing name is backend secrets. It's what that will be used, okay, for production. As simple as that. Okay, then I close this, then go to live readiness probe. Now remember this, okay? We did this in a past, I think in the past 2 or 3 videos. We created a live readiness probe, an endpoint. And it says the method will be HTTP get, and the path will be /live on port HTTP. As simple as that. Okay, on a port named HTTP. This is the port name. Okay, and it is simply going to be used to check if the FastAPI application is working. Okay, if it is not working, then we know that if we cannot make any requests to /live, then we know that it is dead. So we restart. Okay, Kubernetes will restart the pods. Okay, then the other one that we created in the past videos is the readiness probe. Also we shall use an HTTP GET method, and the path will be ready, and the port will be, of course, the same port. So for ready, remember, we're simply using it, okay, to cut off communication. Once ready doesn't give us response, then we know that number one, either our database is down or Redis is down. So by knowing that, okay, FastAPI will cut off communication to those pods. As simple as that. So /live is for restarting the pods in case they are dead. Ready will be used for cutting off communication or cutting off requests from going to our pods. And then we have a configuration or specification saying initial delay seconds, which is a value of 10 here and a value of 5 here. Okay, it simply means take a delay of 10 seconds before you call the liveness probe, or take a delay of 5 seconds before we call the readiness probe. Okay, nice, very simple. Then after that, we have the API service. Okay, so a service in Kubernetes, actually very simple concept. It simply gives you a stable address, because you see these pods, okay, these pods keep changing. Okay, they can be destroyed and created, destroyed. Because of that, they easily, okay, change their IP addresses. Every time you create pods, they have different addresses. But using a service, you have a stable network address, okay, that can be used to point to those changing pods. So on line 1, we have the core version, which is version 1. The kind is a service, okay, like we've been seeing before. Okay, this other one, the kind was deployment. This other one, the kind was config map. So they change. Then after that, we have, sorry, I've gone to the wrong one. I have to go back to service. Here we have metadata. Okay, the name of this service will be the release name dash API. Okay, then the spec is now the service specification. The type will be cluster IP. Cluster IP simply means that it is only for internal use, only, or can only be accessed internally. If we want to use it on our machine, we shall use port forwarding, and I'll show you how. Then we have a selector, again, which is used for finding. Okay, it's a label. So the selector says app release name API. Okay, it will be called Arrow Backend API. Okay, and the ports, okay, so will be the name HTTP. So using Arrow Backend API, okay, it will look for pods. Okay, let me go here. Okay, if you look at this, okay, up here, okay, we have that label consistent with what we have here. Are you seeing this? So this service will use that label to find pods named that, okay, on a port named HTTP. Remember, we have a port, okay, named HTTP, but this is the name here for the service, okay, and the port value will come from values.service.port. Okay, as simple as that. Then the target port is HTTP. Target port actually is this name, is referring to this here. Okay, if you see this name, or is it this name, HTTP, okay, matches this. All right, now I want to deal with Marvelous's question. Okay, this is all you have to know for this session. Make sure you read this or watch this video as many times as you can, and trust me, you will understand these concepts. They're very easy. So Marvelous asked me an interesting question, okay, which I'm going to explain now. He asked me a question: what's the difference between AWS, Hostinger, and, do I remember? I think I wrote it somewhere here. And render. I think I'll use a box or a piece of text to explain that question. So give me a moment. So just a moment. Let me make this bigger. Okay. All right. I think this is big enough. So let's start with AWS. Okay. Number one, AWS is a company, okay? Like, AWS is a company. Render is also a company. Stinger is also a company. And of course, many of you may know or may not know about them, but it's still okay. They're simply a Google search away. So I'll start with AWS. AWS provides several services, okay? And one of them that he asked about was EC2, okay? Which stands for Elastic Computing Service. So EC2, think of it as this, okay? Assuming you have your computer, marvelous, okay? You have your computer, okay? And your computer, you have maybe RAM, okay? RAM of maybe 10 GB, okay? And you have disk space of 100 GB, okay? But for you, you only use, okay, on your computer, 2 GB, okay? So you use only 2 GB, 2 GB, okay, in your RAM, and on for your disk or SSD, you use only about 3 GB, okay? So here 3 GB, here 2 GB. Now what happens to the remaining? Okay, it's underutilization. Okay, a lot of underutilization. So what happens is you can decide to rent out. Okay, you say maybe you give me 2 GB here. Okay, you give another person maybe 5 GB. Okay, here you can. So here you've rented out your RAM. Okay, or your memory. Okay, you rented out your memory. Here this is disk space. Okay, also you can decide to rent out here some disk space. Maybe say you're going to give somebody maybe 10 GB, okay? Another person, you're going to rent out to them maybe 40 GB of disk space, okay? So that you fully utilize it. And maybe this machine is running a Windows machine. And let's just say you're very rich, you have another machine, okay? You can have another machine maybe having maybe either Mac, okay? Or it can be Linux, okay? Can be anything. So what AWS EC2 is what I just described to you, okay? They offer you machines, but now this time they offer virtual machines, okay? Whereby inside, instead of having a physical machine like this, which you've rented out, okay? You create a piece of software, okay? Like this, marvelous, okay? Whereby here, okay, you have this physical machine, okay, in your maybe bedroom or server room or wherever, okay, in your garage, okay, is a physical Windows machine, okay. You can have here, okay, a tool, okay, called a hypervisor, okay, that makes you have other operating systems on it. For example, maybe let me do this, okay. You have your hypervisor software. And this is what AWS actually does, okay? Let me just call it hyper to make it short. Hypervisor. Okay, I can complete it. I was trying to run away from writing, but looks like there's no way for me to run. All right, so you have your Windows machine, okay? And using this hypervisor, you can run a Mac software here, Mac OS, okay? You can run Mac OS, okay? Here, you can run Linux space, or even another version of Windows, okay? Because you have a lot of space, okay? Very powerful machine. And on this particular Mac, you can rent out this to somebody. You can rent out this to somebody. You can rent this one to somebody. That is what AWS EC2 is, okay? Raw virtual machines, okay? So you find that like, these virtual machines are given to people, okay? And you rent them out and you're able to log in into this machine, although it's your own computer, okay? Install maybe JavaScript, I mean, not JS, not JavaScript, of course, because we know it just runs in the browser automatically, it's interpreted, but install not JS, Java, whatever, Docker, Kafka, Kubernetes, okay, and have your own custom machine. Okay, so these physical servers are somewhere, maybe in a data center, maybe in, I don't know, maybe South Africa, maybe California, depending on the region. Okay, because AWS puts these machines in particular regions in the world. Okay, so you be able to rent out that space. So that's what AWS gives. That's what AWS EC2 is: a fully set virtual machine or computer that could be running either Mac, Linux, whatever operating system, every number of operating systems. Okay, so you get that they call them images. Okay, that you can log into using SSH, install your dependencies, run your application, and using it you can use networking, okay, to expose them to the internet. Do you understand EC2? I guess everybody else, at least Marvelous, is one I'll be waiting for to make sure that he has understood, because he asked this question. So that is what AWS EC2 is. Okay. Then you have Render. Render is another company. Remember, with EC2, you log into the machine, the computer, maybe clone your code, install Python, install all your dependencies, okay, and run it. Now, Render is just another company. With Render, you don't have to go through the pain, okay, of creating a machine. Remember, when you're creating this machine, you ask yourself, okay, you have to choose, is it a Linux machine? Is it going to be Windows? What is it going to be? Okay, how much space do I need? Is it 10 GB, 5 GB? I need memory. How much memory do I need? Okay, I need to log in. I have to clone my repository. I have to install Python. I have to install maybe JavaScript and Node.js, React, configure them, build them. After it's running in the machine, you still now need to understand networking and get that machine which is running inside your machine, connect it via AWS, okay, using the networking principles, okay. There's something they call inbound and outbound rules, or set up an AWS load balancer and do all that thing, all that configuration. Set up your domain, SSL, whatever. Go through a lot of headache, okay, for it to be known on the internet. But with Render, okay, you simply give them your GitHub, connect your GitHub repository, okay, your GitHub repository, and they do for you all this pain here, okay. They create for you your machine, okay. They clone your repository inside that machine, okay. They, okay, clone the machine, clone your code, okay. There's also creating. They create the machine, okay. They install your application dependencies, okay. They configure for you all of SSL, everything, okay. They handle for you if you want, I don't know, stuff like maybe load balancing, it's possible, okay, everything, and they give it to you, what they call platform as a service, okay. This one is the infrastructure as a service, EC2, okay, but you don't need to know those terms, infrastructure. What the core concept is what matters. So Render does everything for you, okay. And of course, if you need more control, it is there, but not much, okay. So you give them their code, your Node.js code, your JavaScript code, your Java code, your Python code, whatever code you have, okay. And they, in simple, it's very simple, minimal configuration, okay. They set up and deploy for you, okay. So with AWS EC2, it is harder, okay, more control. Render, it is easier, lesser control. Okay, hope now you understand now the difference between EC2 and Render. Now we go to the famous Hostinger. Okay, Hostinger is another company. What does Hostinger do? Okay, Hostinger also helps you to deploy applications. For example, WordPress. Okay, WordPress is a tool that can help you to build websites, landing pages without having to know how to code. Okay, and it also has its own website builder. Okay, so for simple businesses, okay, they have something that can build for your website, okay, and you deploy it to the internet without having to even code, meaning there's no need to give them your GitHub repository. Okay, they create for you the machine, they set up SSL, everything for you. Okay, even sometimes domains they can help you get a domain easily. You get, and you deploy very easily. But this same hostinger has something called VPC. In full, it is a virtual private cloud, which is very similar or equivalent to EC2, where you can create or buy your own machine, a virtual machine on the internet, and go through the processes I talked about here from scratch. Okay, so it is the easiest. So if you have like a very simple landing page, okay, you can use Hostinger. Or if you don't know how to code, you can use their website builder or use WordPress. Okay, so Hostinger is the easiest for people who don't know how to code. Okay, or even you know how to code, but you want to do it something maybe it's very basic, it's a simple business landing page that you want to set up. Hostinger can help you like that. But also they have a option whereby you can have what AWS EC2 gives you. But AWS EC2 is way more powerful than their VPC option. Okay. In fact, even AWS has VPCs, but let me not go into that. Okay. Then render is the next level of easiness. Okay. A little bit easier, medium. Then you can say EC2 is the hardest. So Marvelous has a question, says, means due to the vastness and complexity of AWS and GCP, that's why recruiters go for it compared to the providers. Yes, that's correct. And of course, it depends which recruiter the person is looking for. Because imagine you have a tool like maybe YouTube. You cannot use Hostinger. That's laughable. You're not going to use Render. That's laughable. You need GCP or AWS because you have way more power. Okay, control. Because with AWS, you have to learn so many things. You must know Linux. You must know about virtual machines. You must know understand networking. You must understand several things. You might even need to get into things like containers and Kubernetes. Okay, you cannot work with Kubernetes on Hostinger. Eh? You can't. Impossible. But of course, in situ you can. Yeah. So yes. So I hope you've understood Marvelous. The difference between these. So if you're aiming for those top companies, okay, as a DevOps engineer or a backend engineer, it will be very valuable if you understand AWS, EC2, or their services. Yeah, and very soon I want to get into AWS, but let me not overpromise. That will come later. Yeah, so that's it for today's live stream. I hope you guys have got something. Yeah, I want to end it now, and I'll see you in the next live stream or the next video. Anyway, I will stay for maybe a question or two in case anybody has a question. All right. Thank you, Marvelous. Thank you, everybody. Bye for now.